Hello, I'm Nathan.
I'm Seth. And I'm Sharia.
We are all in fourth grade.
Our team name is the Master Builders. And our robot name is Mastermind, which stands for Mastermind Storms, not the book.
Our goal was to go forward, get the green medicine bottle, bring it back, put it down, then go straight, connect the blue quilt, then turn on the TV monitor, and come back. If this all goes well, we will get 88 points.
Some of the problems we had is that the robot kept crashing and it also turned too much to the right and too much to the left, and sometimes the color sensor did not sense the green bottle. The solution to these problems were to make the color sensor closer to the green bottle so that it could be sensed, and make it angle when it goes forward in order to not hit other objects. Also, we changed the degrees of the turn so they didn't turn too much or too less.
This project will help us with the 2017 FLL Hydrodynamics project. It helps us because it helps us build a robot and work with a team.
Another way it helps us is that we learn how to get our robot around the board to do our missions. Two more ways that helped us was it taught us to do some missions like flipping switches before doing harder missions like getting medicine bottles. Also, just because a challenge is hard doesn't mean it gives us a lot of points.
And here is our slide. Master Builders, the coolest team in FLL. Who will win?
The process we took to build our robot. We used the process of RSDLC to build our robot. This process helps us so that we're able to make our robot do what we need it to do, and also so that it won't fall apart all the time. We designed a robot. We made a robot simple but sturdy. We also added some extensions we needed to make it complete our job. Its name is Mastermind.
Goals. Our goals was to Our goals were to pick up the green medicine, come back, put together the quilt, then flip the TV monitor, come back, and yeah, that's it.
Building. Our build was actually really good, and it turned out how we wanted it to be. But although sometimes it fell apart, and we realized that some of the pegs were too loose, and that's why. There are 3 systems that we use in building. The first one is called the static system. The static system is a system where basically the base, and it doesn't move on its own, but it helps in your robot. And some of our static components were like these parts, and then the little shovel. And the next system is the dynamic system, which is able to move on its own. The dynamic system includes gears and axles. The last system is the electronic system. The electronic system allows us to move our robot using motors, sensors, and, of course, the EV3. Some of the components in the electronic system are the EV3, wires, sensors, and motors.
Our program makes the robot.
No, we didn't. No, we didn't.
Our robot first moves towards my left until its color sensor senses green. Then it picks up a bottle and the green bottle and brings it back to the base. Next, it has the other two quotes and it attaches them. Then it flicks the TV monitor and comes back to the base.
We tested many times. Not all times it worked. Sometimes, mostly it did not work, sometimes it did work.
Rethinking. Rethinking is after you test it, you look at the bugs or problems in the program and you go back to it and look at what might have caused that problem. Either it's the program or a wire got stuck on your wheel.
Yeah.
And then you change the program or take the wire off the wheel and then you run it again and repeat the process of rethinking, of testing and rethinking.
So when our robot was done, we played with it to make sure that it was consistent and it didn't fail after it worked once.
Thank you for listening.
We hope you enjoyed.
P.S. We might win.